In this video, we are going to be talking about HTTP, Hypertext Transfer Protocol. So HTTP is really the communications backbone that we use for RESTful APIs. And just a little bit of history about it. The development was started by Tim Berners-Lee of CERN back in 1989. So HTTP 0.9 is the original proposal. It started off as a telnet-friendly protocol. So a little bit of history. You can literally do a telnet to google.com on port 80. It will connect to it, and you can issue HTTP commands right from a telnet session. I'm not sure if modern computers still include telnet or not. You might have to install that manually, but back in the day, Unix and Linux, that was kind of the standard was to use telnet, even though it was free text. But you get back to the 70s and 80s, that was the tool to use. And you literally could go to port 80 at a website and use Telnet and issue HTTP commands, which is effectively what your browsers are doing. So a little bit of history of that. From 1991 to 1995, that is really where we saw a lot of growth in HTTP and HTML. These are two different technologies, but they work well together. Basically, new software, we now know it as a web browser, emerged, and HTTP was used to transport HTML documents. So HTTP, think of that as the transport mechanism. HTML is the actual document. And in terms of RESTful interfaces, we are going to be using with JSON. So it's just a different format of text that is going across the wire, across the HTTP standard. So HTTP standards were developed by IETF, the Internet Engineering Task Force, and also W3C, World Wide Web Consortium. I don't want to say governing bodies. They effectively are governing bodies. I don't think that they're related to governments, but they are associations that do help agree to standards that drive the internet. So HTTP1, this is an example of that. So you can see here, telnet to a website, you issue a GET command, and that is going to provide back a response. You can see the box of 2, the little red 2 there. That is the response that will come back. This is going to be text coming back. So you'll get HTTP 200, which is an OK content type. These are headers. And then you'll wind up with a body as well. So if you've never seen raw HTTP, this is it. This is what's actually going across the wire between your browser when you're making requests from websites. That's really what's happening at a lower level, which is obscured to you. Now, in 1997, HTTP 1.1 was released. This solved a lot of ambiguities from the earlier versions and also added support for keep alive connections, chunked coding transfers, and byte range requests, transfer encodings, and request pipelining. So a lot of efficiencies were added to this. HTTP 1.1 was updated by RFC 2616 in 1999 and updated again in 2014. And this is still widely used today. Here you can see in 1.1 the request added encoding character set and cookies. Everybody loves cookies, I know. And then also on the response, that also added encoding character set and cookies as well. So the request and response were updated in these two releases. Now, HTTP 2 came along in 2015. This was originally named HTTP 2.0. By the end of 2015, most servers and browsers supported this. As of October 2021, 47% of the top 10 million websites supported HTTP 2. It does have a high level of compatibility with HTTP 1. As developers, there's really no functional difference between the two of those for us in terms of our concern. A lot of it was more lower level functionality, especially between 1 and 2. As far as writing RESTful interfaces, absolutely the same for us. For HTTP 2, the performance is really more the focus of that. So it does improve page load speed, lower latency, higher throughput. This is really for our concern. We can get more performant APIs through HTTP 2. So as developers, we want to be using it, but whether we're using 1 or 2 there's functionally no difference for us. Now, more recently, HTTP 3 was accepted by the task force in 2018, so this is fairly recent. As of summer 2022, HTTP 3 is supported by 73% of the browsers and about 25% of the top 10 million websites. This does build on HTTP 2. The biggest change of 3 is to use a quick network protocol rather than TCP. There really are no significant changes for us as developers writing RESTful APIs. That they virtually are the same. The commands are the same. All the standards are the same that we are going to be using. As far as in the Java community, it's still kind of early as far as adoption. There are Java-based servers that are supporting HTTP 3. It is rapidly changing. I expect a few years down the road, this will be the standard because there are advantages to it in terms of efficiency. To help you visualize the differences here, just the protocol stacks. So going from the bottom up, we are still using the IP addressing. HTTP 1, 2, and 3 rely upon TCP. And then HTTP 1, that optionally uses TLS and SSL. So that is what gives you encryption over the wire. HTTP 2 uses TLS 1.2 or greater. So by default, that is going to be a secure transport protocol. However, HTTP 3, that uses the QUIC protocol and also TLS 1.3. So 2 and 3 by default are going to be secure protocols. 1, that is where you can send that free text across the wire. So something to be aware of it as far as working with these protocols. Again, this is evolving. For us, the flavor, whether it's 1, 2, or 3 as developers, the calls that we're making, the status codes, the methods that we have to utilize are all the same. But it is important to be aware of how HTTP works and the status calls that we are going to be working with, because as we write RESTful APIs using HTTP and the features of HTTP are very important aspects of how we code our APIs.